On a quiet night, when you're sitting alone on a rooftop and looking up at the sky, everything feels calm. The stars are shining, scattered across the darkness, each one looking like it belongs exactly where it is. The universe feels peaceful, but every story has a villain. And even in this cosmic celebration of light, there is something hidden, an invisible darkness that exists between the stars, a place where even light is afraid to go. This is one of science's greatest mysteries, the black hole. The name sounds simple, almost harmless, but a black hole is not just a hole in space, it's a trap, a one-way doorway where anything that gets too close is pulled in forever. Its gravity is so powerful that it can swallow a star as massive as our sun without making a sound. Scientists study black holes from a safe distance because they represent a region where the known laws of physics begin to collapse. Near a black hole, reality itself becomes uncertain. The story of a black hole doesn't begin in darkness. It begins with light. It starts with a massive star, many times larger than our sun. For millions or even billions of years, that star burns bright, releasing enormous amounts of energy. But nothing lasts forever. When the star runs out of fuel, its own gravity turns against it. The core collapses inward, triggering a colossal explosion known as a supernova. The outer layers are blown into space while the core continues to shrink, compressing an unimaginable amount of mass into an incredibly small point. That is how a black hole is born. Once formed, a black hole never stops pulling. Gas, dust, stars, anything that comes too close is dragged in by its gravity. The most dangerous region around a black hole is called the event horizon. This is the boundary of no return. Cross it and escape becomes impossible. It's like drifting toward the edge of a waterfall. As long as you're near the edge, you still have a chance to turn back. But once you pass the point where the water drops, there's only one direction left: down. What makes the event horizon truly strange is that the person falling in wouldn't feel anything special at the moment of crossing it. There's no sudden shock, no alarm, no warning. Everything feels normal. But to someone watching from far away, time appears to slow down. The falling astronaut seems to freeze, fade, and slowly disappear. One event, two completely different realities. Near a black hole, even time becomes relative. Inside the black hole, all connections to the outside universe are cut off. No signals can escape. No information can be sent back. Space and time lose their familiar meaning. In normal space, you can move forward or backward. Inside a black hole, there is only one direction, toward the center. Light bends, shapes distort, and reality itself seems to twist. It's a place where imagination struggles to keep up with what physics predicts. Time behaves in a shocking way near a black hole. According to Einstein's theory of relativity, gravity slows down time, and nowhere is this effect stronger than near a black hole. If someone could spend time close to one and then return, they might find that thousands or even millions of years have passed on Earth. In that sense, a black hole acts like a natural time machine, but only one that moves forward into the future. Then comes one of the most terrifying ideas in astrophysics: spaghettification. Because gravity near a black hole is much stronger closer to it, different parts of your body would be pulled with different forces. Your feet would feel a stronger pull than your head. The result is horrifying. You would be stretched longer and thinner, like spaghetti, until your body is torn apart at the atomic level. In smaller black holes, this happens before you even cross the event horizon. In supermassive ones, it happens deeper inside. Either way, survival is not an option. At the very center of a black hole lies the singularity. This is a point with zero size and infinite density, where all the mass is crushed into nothingness. Here, our understanding of physics completely breaks down. Space ends. Time ends. Science has no clear answers. Some scientists believe that singularities might be connected to the birth of new universes, just as our own universe began with a singularity during the Big Bang. It's possible that every black hole hides the beginning of something new. There are also theories that black holes could be gateways, wormholes connecting distant parts of the universe, or even entirely different universes. In these ideas, a black hole would be an entrance, and a white hole would be the exit, pushing matter back out instead of pulling it in. These concepts are popular in science fiction, But so far, there is no direct evidence that wormholes or white holes actually exist. For now, they remain powerful ideas waiting for proof. In the end, black holes remind us how small we really are. Earth is just a tiny grain of dust in an enormous surface. Yet our curiosity has no limits. We ask questions that stretch across billions of light years. Maybe we'll never know what truly lies beyond a black hole. And maybe that mystery is the point. The questions themselves are what make us human. So the next time you look up at the night sky, don't just see the stars. Notice the darkness between them. That's where the universe keeps its deepest secrets. On a quiet night, when the world finally slows down and you find yourself alone under the open sky, something strange happens. The noise of daily life fades away. Your thoughts become quieter. Above you, millions of stars shine effortlessly, scattered across the darkness like tiny beacons of light. Each star feels calm, distant, and perfectly in place. It feels like the universe is at peace. But every story, no matter how beautiful, has a shadow. And hidden between these glowing stars is something far more powerful than light itself. Something invisible, silent, and terrifying. A darkness that doesn't just exist, but waits. That darkness is called a black hole. The name sounds simple, almost misleading. A hole suggests emptiness, a gap, something hollow. But a black hole is not empty at all. It is the most extreme object known to science. A region of space where gravity becomes so strong that nothing, matter, energy, or even light, can escape once it gets too close. It doesn't glow, it doesn't shine, it doesn't announce its presence. You only know it's there by the way it distorts everything around it. Black holes are not monsters with teeth, but they are cosmic traps, silent hunters hiding in the dark. Scientists consider black holes one of the greatest mysteries of the universe because they exist at the edge of what we can understand. Near them, the laws of physics, the very rules that explain how reality works, begin to break down. Space bends, time slows, cause and effect blur. A black hole is where our confidence in science turns into questions. But black holes are not born from nothing. Their story begins with something incredibly bright. It begins with a massive star, far larger than our sun. For millions or even billions of years, this star burns furiously, producing energy through nuclear fusion in its core. That energy pushes outward, perfectly balancing the star's own gravity pulling inward. This balance keeps the star stable, alive, shining. But nothing in the universe lasts forever. Eventually, the star runs out of fuel. The fusion stops. And when that happens, gravity wins. The star collapses under its own weight. In a final, violent act, it explodes in a supernova, one of the most powerful explosions ever witnessed in the cosmos. For a brief moment, it can outshine entire galaxies. The outer layers of the star are blasted into space, scattering heavy elements that may one day form planets or life. But the core doesn't escape. It keeps collapsing, shrinking, compressing more and more mass into less and less space. If the core is massive enough, there is no force left to stop it. And at that moment, a black hole is born. Once created, a black hole becomes endlessly hungry. Gas clouds spiral toward it. Stars drift too close and are torn apart. Entire solar systems can be disrupted. Anything that crosses its path is pulled inward by gravity so strong that escape becomes impossible. The closer you get, the stronger that pull becomes. And surrounding the black hole is a boundary unlike any other in the universe, the event horizon. The event horizon is not a physical surface. You can't see it or touch it, but it marks the point of no return. Once you cross it, there is no going back, no matter how powerful your engines are. To escape from inside the event horizon, you would need to travel faster than the speed of light. And according to everything we know, that cannot happen. The event horizon is the universe's ultimate game over line. What makes this boundary even stranger is how differently it appears depending on who's watching. If you were the one falling into a black hole, crossing the event horizon wouldn't feel dramatic at all.